Hello, we are on page 28 and we are going to be briefly talking about types of chemical reactions. So last year in pre-AP you learned about some basic types of chemical reactions that we see here. The first we're looking at is synthesis. In a synthesis reaction, we are synthesizing or making something. It's always two or more substances coming together to make one new substance. So we will always have only one product formed. In a decomposition reaction, it's just the opposite. One substance is breaking down into simpler substances. So in this case, we're always going to have just the one single reactant. In a single replacement reaction, just like that sounds, a single element is replacing another in a compound. So we see here A has kicked B out. On the product side, B ends up all alone, and now AC is a compound. In a double replacement compounds, we have two ionic compounds that are switching places to form two more. So our cation and our anions are going to split up. Cation goes with new anion, cation with new anion. Cation is always written first in that chemical formula. And lastly, we have a combustion reaction. In a combustion reaction, our substance, which is generally a hydrocarbon, always react with oxygen, and the products are always going to be water and carbon dioxide. Large amounts of energy are also released in that combustion in the form of heat and light. Within this double replacement subsection, that's probably the most important part for AP Chemistry, and there are three different types of double replacement reactions that we need to be able to recognize as well. The first type of double replacement reaction that we need to recognize is a precipitation reaction. In a precipitation reaction, we have two aqueous solutions mixing to form that precipitate or that solid. So we can see here in our double replacement, one of those products was a solid, aka the precipitate. The next video is going to go much deeper into precipitation reactions and net ionics. Another type of double replacement reaction is our neutralization or acid-base reaction, where an Arrhenius acid and base react to form a salt and water. Remember, an acid is always hydrogen with some other anion, so B is that case there. And then a Arrhenius base is any of your metals with hydroxide. So our hydrogen and hydroxide come together to form the water, so that acid and the base part are neutralizing each other into neutral water, and then the cation and the anion come together to form the salt. So acid-base reactions are always going to produce water and a salt. Be looking for that hydrogen and OH on your reactant side. Lastly, we have gas evolution reactions. So here we have two aqueous solutions mixing, and they're going to form a gas. There are four different main gas evolution reactions that you should be able to recognize. The first would be when we're forming a sulfide. So we're going to form hydrogen sulfide gas. The rest of them, we see that we have intermediate products that are formed. So these are products that are formed but are not stable, and they end up breaking down further. So if we ever form hydrogen carbonate in a reaction, that is actually going to further break down into CO2 and water, and those would be our actual products. Similarly, if we ever form hydrogen sulfite, that is going to break down into sulfur dioxide and water. And lastly, ammonium hydroxide is again also an unstable intermediate product. It's going to break down and form ammonia, gas, and water. So we can see in all of these that water was kind of taken out, and then it was whatever was left over was the gas that we formed. Another type of reactions that we need to be able to recognize is oxidation-reduction reactions. In an oxidation-reduction or a redox reaction, electrons are transferred from one atom to another. The substance or the atom that is accepting an electron is going to be reduced, And the substance that is losing an electron is going to be oxidized. Electrons are always transferred from the oxidized species to the reduced species. So if it's losing something, it's not just losing them, it is giving them to something else, the one that accepts it, which is reduced. So to help us remember that, we have a couple different mnemonics. We have oil rig. So oil rig, the OIL stands for oxidation is loss, the rig stands for reduction is gain. And then we have Leo goes GR. Leo stands for losing electrons, oxidation, and GR, gaining electrons, reduction. We are going to talk so much more about oxidation-reduction reactions in Unit 3. For now, the big key thing that we need to know is our definition. So reduced again is accepting, losing is oxidation. So pick a mnemonic to remember that. And we also need to be recognized that almost all reactions are going to be redox. The only type of reaction that is never ever redox is double replacement. Okay, so that is a little briefing on our different types of reactions. Continue on to the next video to learn way more about our precipitation reactions.